Example 5. We want to evaluate this. It says sine of inverse tangent of 3/2. And what you need to understand is that this inverse trig function is talking about an angle. So understand that that part is an angle, and so it's like we want sine theta is basically what we want, okay? We want sine of some angle. And so let's draw a picture of this angle, okay? So for tangent, I know tangent is defined in quadrants 1 and 4. Remember the range? The range for tangent was negative pi over 2 to positive pi over 2, which is defined in quadrants 1 and 4, okay? It's defined in quadrants 1 and 4. From negative pi over 2 down here to positive pi over 2 up here, that's defined in quadrants 1 to 4. So the fact that this is positive, 3/2, okay, means that, all right, if you're in quadrant 1 or 4, the positives are upstairs and the negatives are downstairs here, okay? And so the fact that that 3/2 is a positive number would indicate that I'm in quadrant 1. And so I'm going to draw this angle in quadrant 1. I think that's the hard part. Being able to determine that we have an angle in quadrant 1, I think that's the hardest part of this. So if you've got some angle, and we called it theta, so label your angle. I'm seeing some students that are not labeling their angles. It makes it harder on you, I think. And then the tangent ratio, we know tangent is y over x. So the tangent ratio, y over x, is 3/2. So that's the y number and the x number, 3/2 right there. We should be able to do Pythagorean theorem to find the hypotenuse. 2 squared plus 3 squared equals c squared, or r squared, I guess. That's 4 plus 9 is 13. But 13 equals c squared. This will be the square root of 13. That hypotenuse is square root of 13. Okay. Now here's why this is so easy. Remember when I wrote down that we're finding sine theta? Just look at your picture. You ought to be able to look at the picture and tell me what sine theta is. Just look at the ratio. You know the sine ratio is y over r. So look at your y over your r number. Your sine ratio is 3 over square root of 13. At which point all we would do is rationalize. Rationalize the denominator in the usual way. We have 3 square root of 13 over 13. And that's right. Okay? So I think the hard part is just knowing where to draw your picture. So if I look at part B, it's tangent of inverse cosine of negative 5/13. Now again, this is an angle. So if you think of that as an angle, theta, we're just finding tangent theta. Okay? But we need to draw a picture of this angle. So, look at inverse cosine. And the range for inverse cosine was from 0 to pi. So it's really important that you can figure out the ranges. Okay? So if we're from 0 to pi, that's talking about quadrants 1 and 2. But what you're going to notice is this negative right here, that's a negative number. And so what quadrant is this angle going to be located in? Second quadrant, because that's where the negative numbers would be. Okay? So the fact that that's a negative 5/13 is indicating that we are in quadrant 2. So let's draw a picture. Let's draw our picture in quadrant 2. We've got some angle taking us into quadrant 2. But we're going to form a triangle out of that. And label that, label that theta. Just go ahead and label it. People aren't labeling it. But we've got the cosine ratio of negative 5/13. Okay, remember cosine ratio is x over r. And so your x, let's call that negative 5, and your r is 13. So you've got that cosine ratio of negative 5/13 in the second quadrant. We need to find the missing side. Okay, the missing side right here, and some of you might already know it because this is one of the special patterns that comes up all the time. But if you don't know it, you're going to say something like y squared plus negative 5 squared is 25 equals 13 squared and 169. I'm just doing Pythagorean theorem basically. Subtract, and that's 144. square root, you're going to get plus or minus 12, but in the second quadrant, we know y numbers are positive, so that's positive 12. Okay? So we've got all the hard work done. All we need to do is find this tangent ratio. Tangent theta, remember the ratio for tangent is y over x. So you look at your y over x is going to be 12 over negative 5, or negative 12 fifths.